Okay, so again, we've got the first derivative of the given function. Now we will get the second derivative of the function using the first derivative of the original function. Now, okay, so since our first order derivative is equal to 12x cubed minus 27x squared minus 8x plus 12, we can solve it now. We can find the second derivative. So y double prime is equal to dx of 12x cubed minus 27x squared minus 8x plus 12. So derivative of 12x cubed, that's 36x squared, minus the derivative of 27x squared, that's 54x, and the derivative of 8x is 8, so negative 8 here, and derivative of 12 is equal to 0. So this is the second derivative of the function, 36x squared minus 54x minus 8. So we've got the first derivative of the function, and we've got also the second derivative of the function. Okay, so another problem here. Let y is equal to 3x plus 5 all over x squared plus 4. Now we will get the second derivative of the function. Now, according to quotient rule, the derivative of the numerator divided by the denominator is equal to the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the original denominator squared. Now, if we're going to solve with the given function here, so the dy dx is equal to the to x squared plus 4, or the denominator, times the derivative of 3x plus 5, the numerator, minus the numerator, the original numerator is 3x plus 5, times the derivative of the denominator, which is derivative 3x of x squared plus 4, all over the denominator, or x squared plus 4 quantity squared. Okay, so we will solve x squared plus 4, derivative of 3x plus 5 is 3, minus the 3x plus 5, times the derivative of x squared plus 4, that's 2x, all over x squared plus 4, quantity squared. Okay, let's expand the numerator, so x squared plus 4 times 3, that's 3x squared plus 12. Minus the 3x plus 5 times 2x, that's negative 6x squared minus 10x. We will combine the like terms, so 12 minus 10x minus 3x squared all over x squared plus 4 quantity squared. This is the first order derivative of the function. Now, according to our problem here, we will get the second derivative. So we will not yet done. So using the first derivative of the function, which is 12 minus 10x minus 3x squared all over x squared plus 4 quantity squared, we will get the second derivative of the function. Okay, so the same principle, using the quotient rule, we will get the derivative of the function. So the derivative, or the second derivative, is equal to the derivative of the first derivative of the function. So first is that we will expand the denominator. So x squared plus 4 quantity squared, that's equivalent to x raised to the 4th plus 8x squared plus 16. Okay, so we will use the quotient rule to get the derivative of the function, which is the denominator x raised to the 4th plus 8x squared plus 16 times the derivative of the numerator, so ddx of 12 minus 10x minus 3x squared, minus the numerator, 12 minus 10x minus 3x squared, times the derivative of the denominator, so ddx of x raised to the 4th plus 8x squared plus 16 all over the denominator squared. So that's x raised to the 4th plus 8x squared plus 16 quantity squared. Okay, so we will expand this. No, we will solve this, the derivatives first. So x raised to the 4th plus 8x squared plus 16 times the quantity of 12, that's 0, minus the derivative of 10x, that's negative 10. Derivative of negative 3x squared, that's negative 6x. Minus 12 minus 10x minus 3x squared times the derivative or of x raised to the fourth, that's 4x cubed. Derivative of 8x squared, that's 16x. And derivative of 16 is 0. Okay, so we will expand this one. So x raised to the fourth plus 8x squared plus 16 times the quantity of negative 10 minus 6x. That's negative 10x raised to the fourth minus 6x raised to the fifth minus 80x squared minus 48x cubed minus 160 minus 96x. Next is we will multiply this one, negative times 12 minus 10x minus 3x squared times the quantity of 4x cubed plus 16x. So that's 48x cubed or negative 48x cubed minus 192x plus 40x raised to the fourth plus 160x squared plus 12x raised to the fifth plus 48x cubed all over x raised to the fourth plus 8x squared plus 16 quantity squared. Now we will combine like terms here in the numerator. So this is 6x raised to the fifth plus 30x raised to the fourth minus 48x cubed plus 80x squared minus 288x minus 160. And then over or all over x raised to the fourth plus 8x squared plus 16 quantity squared. So this is already simplified. Now this is the second order derivative of our original function, and this is the answer of our problem.